Alright, hey AP Chemistry, this is going over Quick Check 1B for Chapter 6. So we're going to talk a lot about delta H, or enthalpy. This is enthalpy. And these are energy changes associated at constant temperature. So typically, we're going to talk about phase changes here. So things could change phase. I could go from a solid to a liquid. I go from a liquid to a gas. I go backwards. I could go from gas to a liquid. I could go from liquid to solid, or I could go from solid to gas. This is ethyl alcohol, otherwise known as ethanol. It's got a molar mass of 46.08 grams per mole. That means 1 mole is equal to 46.08 grams. We're going to go back to that in a bit. The heat of fusion of ethyl alcohol, or delta H of fusion, that means melting or freezing energy, right, depending on the direction. The delta H of fusion is 4.98 kilojoules per mole. So that would be for melting. If I wanted it to freeze, it would be negative 4.98 kilojoules per mole. For freezing or for condensing, we'll see that I need to remove energy. For melting or vaporizing or boiling, I'm going to have to add energy. And then for the heat of vaporization, right, and this is going to be for boiling, or it'll be condensation. Delta H of vaporization is 39.40 kilojoules per mole. If I wanted to condense, it would be the negative form, negative 39.40 kilojoules per mole. Okay? Now, it says write an equation for alcohol vaporizing. That means going from a liquid to a gas. And it says include the energy value. Now, if I want to go from a liquid to a gas, think about what I want to do with water. If I want water to go from a liquid to a gas, I have to put it on a fire and heat it up to boiling. So I have to add energy. So I'm going to write, instead of writing this all out like this, I'll write it like C2, 2, 3, 4, 5, 6, H6O. I'm going to write it like that. All right, so that's ethyl alcohol. Okay, so C2H6O, and if I'm vaporizing it, that means it must have been at the liquid state, and I have to add energy. So I'm going to say plus heat gives me C2H6O in the gaseous form. Now, if I want to include the energy value, it'll be C2H6O liquid plus, to vaporize, it's 39.40 kilojoules. Gives me C2H6O in the gas form. Sometimes you'll see ethyl alcohol written like this. You'll see it as C2H5OH. You'll probably see that on later pages. So I'm going to show you another way to write alcohols. Alcohols typically have like an OH at the end, so C2H5OH. Just another way of writing this equation. This is how we're going to write phase equations. And you need to recall heating and cooling curves, which will be in a different video. But remember, if I'm going from solid to liquid, I need to add energy. If I'm going from liquid to gas, I need to add energy. Remember our heating curves from a long time ago, right? So solid to liquid, liquid to gas, gas. Okay? All right. Now it says change on the particulate level. If alcohol molecules, these are the alcohol, represented by these big circles, draw before and after. If I'm a liquid before, let's draw like a couple of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So that's my liquid. Particles are kind of close together. They're not in any uniform way. There's no geometric pattern, so I know it's not a solid. If it was a solid, they would be in order. And then if I want it to be a gas afterwards, I'd probably draw those 10 particles all over the place. 3, 4, 5, 6, 7, 8, 9, 10, okay? Let's just assume that those are gas particles all over the place, okay? So, just need to remember that how I represent solids, liquids, and gases on a particle level, and that this requires energy. It requires energy to separate. That is why the delta H of this is positive 39.40 kilojoules for every mole. Okay? If I wanted to go this way, I would remove energy to get them to be closer together, and the delta H would be negative 39.40 kilojoules per mole. Okay, now let's do a couple of calculations with this delta H. How much heat is needed to boil 10 grams of ethyl alcohol? Now, for these type of equations, we can use an equation. Q is equal to NH. Now, on worksheet number 4, I mentioned Q equals MH, but this is an equation, it's not given in the textbook, not given, but it's a way to relate the amount of heat with enthalpy, delta H. Okay, so we can use this, where Q is the amount of heat required, N is my moles, and H is my vaporization energy or my fusion energy, whatever H we're talking about here. So it says how much heat is needed to boil 10 grams of ethyl alcohol. Now, I don't know what Q is, and N is going to be moles, but I have 10 grams, so I'm going to have to go from 10 grams to moles, and remember, to do that, I have to divide by the molar mass, which was given to us before. And then my H to boil, that's H of vaporization, that's going to be my 39.4 kilojoules for every 1 mole. Okay? Now I'm going to do the math down here, but if I want to go from grams to moles, I'm going to divide by my molar mass, which is 46.08. I'm going to do it using dimensional analysis, or I'm just going to show it right here. 10 divided by 46.08 grams, okay? That's going to give me 0.217 moles of the alcohol. Okay, so prove to yourself that I did it over here. I'm just dividing by, let's say it was 1 mole by 46.08 grams. I'm dividing by the molar mass. Remember, to go from grams to moles, you divide by the molar mass, and I got 0.217 moles. I have my H, I have my moles, I just have to multiply them together. Q is equal to NH, equals to, so I'm going to bring that over here. Q is equal to 0.2, so I have 0.217 moles, and then I have 39.40 kilojoules per mole. I don't have room for this here, so I'm going to bring it up over here. I was doing that before. 217 moles, 39.40 kilojoules per mole. And notice how moles will cancel out, and I'll end up with 8.55 kilojoules to boil. And this is positive. So Q is equal to 8.55 kilojoules to boil. So this is one of the first examples, and they don't do too much of this in your textbook, so I wanted to show you this here. This is how you calculate energy associated with phase changes. Let's do another one. It says, how much heat is released when 25 grams of liquid ethyl alcohol freezes? Okay, so now we have to be careful here because we're freezing. Since we're freezing, and I mentioned this up here, the delta H of fusion is equal to 4.98 kilojoules per mole. To freeze, it's going to be negative 4.98 kilojoules per mole. When I freeze, I need to remove energy. So I got my H, right? This is my equation, Q equals NH. This is my H over here. My H is over here. I'm going to look for N in moles. So again, my N, I need moles. My H is going to be negative 4.98 kilojoules per mole. So it looks like my big step work here is to go from grams to moles. And again, this time I'm going to use dimensional analysis. 25 grams of the ethyl alcohol, typically we could write ethyl alcohol as ETOH, times 1 mole over the molar mass, which was given to us before, 46.08 grams, and I get 4 moles. I didn't do that over here on the side. I did all one step. So for my moles, I'll do 25 divided by 46.08, and I get 0.543 moles. Everything's getting a little bit squished over here, sorry. All right, so I get 0.543 moles, and then I could just, if I want to figure out how much heat is released, Q is equal to, my N is 0.543 moles. My delta H is going to be negative 4.98 kilojoules per mole. If I do this math and have the units cancel out, my moles is going to be equal to my kilojoules is going to be equal to negative 2.70 kilojoules, okay, to freeze. Another way of writing this is removes 2.70 kilojoules, okay? So this video did an intense go through and walkthrough of looking at delta H, which will be our enthalpy changes associated with phase changes. So again, enthalpy are energy changes associated with phase changes, typically. We'll see delta H for chemical changes, that'll be a little bit different. But again, if I want to do any type of calculations, I have another equation, Q equals NH. Before there was a video, or you'll see a video where we use Q equals MC delta T, and that's energy associated with temperature changes. This video has no temperature changes. Notice how there was nothing involving temperature here. It's just saying that something boiled or something froze. So whenever we see a phase change, we need to use anything having to do with the energy associated with the phase change and think about our moles to calculate that. So going back to Q equals NH.